Hi, I'm Arthur Wang. This is my buzz card. So this is my presentation on how Taylor series and polynomials can be applied to computer science. So some background. Taylor series and polynomials, as we have learned, are very useful as writing mathematical functions into these forms allows us to approximate the value of a function to a predetermined error. So if we want less error and consequently a better approximation, we can simply take more terms of the Taylor series, just adding on the terms of sequentially higher degree terms of the Taylor polynomial. So a Taylor polynomial of order k generated by f of x at x equals a is given by the general form, and where each term is going to be f, so the kth derivative of the function at a over k factorial times x minus a to the power of k. And here's a graph that shows if the graph would be the green line, so it's like kind of hidden under the blue one. As the order increases, we can see that each line gets closer. So you start with 2 down here, order 3 down here, order 4 up here, but it gets closer. And order 7 by then is very, very close to our actual equation that would be given. Alright, so here's the application to computer science then. Algorithms and functions used in applications such as calculators can use these. So, while it may not be inherently obvious, digital calculations that involve functions employ Taylor series / polynomials to approximate values. For example, bearing in mind that a Maclaurin series is a Taylor series where x equals a, we have the example. To find the value of sine 1 in radians, a calculator will use the Maclaurin series expansion for sine x that we found earlier. So sine x equals x minus 1/6 x cubed plus 1 over 120 x to the 5th minus 1 over 5040 x to the 7th, and so on. So the calculator substitutes into as many terms of the polynomial that it needs in order to get the required number of decimal places. So let's say our calculator has 6 decimal place accuracy. We simulate what the calculator will do by substituting x equals 1 into each of the terms and stopping when the accuracy is achieved. So what does this mean? Since computers cannot store literally infinite possible data and answers to calculations, they can utilize useful representations such as Taylor series / polynomials that can be used to calculate extremely precise approximations of things such as functions. Although we can also technically calculate such approximations of functions by hand, computers can leverage their computational power and calculate these approximations way faster than a human can. So here are the references or the links and for the information and the image sources. Thank you for watching.